Welcome to Self-Hacked Radio, where cutting-edge science meets cutting-edge health. Hello everybody, I'm here with Dr. Alexander Wunsch, who is a physician in Germany in holistic medicine and photobiology. He is the CEO of Medical Lighting Consulting in Heidelberg, Germany. Today we're going to talk about things like the sun, circadian rhythm, and light in general. Now, how does the sun interact with the circadian rhythm? What is the main thing that is setting the circadian rhythm? Is it UV in the eyes, UV on the skin, color spectrum, color intensity, or maybe even infrared has some role in that?
I would like to extend the question a little bit, not only the circadian, but the chronobiological rhythms, because we have to talk about circadian rhythms and seasonal rhythms as well. And we know today that signals from the skin, for example, signals from blood, for example, signals from the hormonal, from the endocrine system, vitamin D as an example, play important role. We know that we have some receptors in our eyes which are good for vision. They play a role because they give us signals regarding our environment. And we have a specific receptor system which is a non-vision forming system. And these receptors, they are very susceptible for blue light, and the blue light content of the light which meets your eyes will directly influence the midbrain, and therefore will be responsible for some hormonal adjustments.
You're saying there's a couple different ways that the sun can reset the circadian rhythm. Some of it is through vitamin D and other hormonal effects. Some is through the blue light in the suprachiasmatic nucleus. Is that pretty much what you're saying?
Yes, the colors, the content of blue, and the ultraviolet radiation which acts onto the skin are responsible for the seasonal, for the circadian, for the seasonal settings.
Now, what are your recommendations for the duration of sun to get a day?
It's very difficult to give a valid recommendation because you have to find it out on your own. This is an individual issue. And you have to learn how your body reacts, and it's a good idea to start with 5 minutes. If the season is right, if the time of the day is right, it's always good to start with 5 minutes and then step out of the sun and watch yourself. And after 3 or 4 hours, you will learn, your skin will tell you if you got a good dose or if you exceeded what your skin can stand. So if 5 minutes are good in the first go for the first day, then you can double the duration for the next day and do 10 minutes out in the sun and so on. But there is, of course, a certain limit because you should not exceed normally 30 or 40 minutes, depending on your individual skin type and light tolerance of your skin.
Is that in the whole day you shouldn't exceed 30 to 40 minutes, or at a time?
I think it's a good advice to not exceed 1 hour, even if your skin is accommodated to sunlight, because it's always a question of dose, and there are benefits and there are negative aspects as well, and the dose is exactly what makes the difference.
How would somebody know if they're getting too much? Let's say, would they get a burn? Is that how they would know? They would increase it from 5 to 10 minutes? If they get a burn, they shouldn't increase it. Or is there any earlier symptoms that they'll know that they got too much?
Yeah, if you get a burn, then it was definitely too much. In phototherapy, we are looking for an erythema, which is a reddening of the skin. There are different gradations of an erythema. And the minimal erythemal dose is normally evaluated by the physician who wants to treat a patient, and you never start nowadays with an erythemal dose. You always try to stay beyond this limit, which means in phototherapy it's just 70% or so of the minimal erythemal dose.
Mm-hmm.
So if you once exceeded the right dose, your skin is not able to compensate for the additional light in a correct manner. So always stay beyond this threshold.
Okay, so you say the maximum amount of sun you should get is 1 hour. But let's say the time of the day that you're getting sun is also going to matter. So if you're getting sun at 9 a.m., in my mind, it would be less of a problem to get an hour of sun. What do you think? Or more? You know, if you're getting sun from like 8 to 10, would that be fine?
I would never say that 1 hour is the correct dose, because you have to evaluate your personal tolerance. And for skin type 1, which is a person with red hair, for example, and green eyes, maybe will not even stand 20 minutes, even after adaptation to sunlight. And people with darker pigmented skin, for example, can easily stand 1 hour. So this is exactly what you have to find out and what you have to evaluate. And of course, the time of the day for the sun exposure makes a big difference. In the early morning or in the late afternoon, you will never get the full benefits from sunlight, because what we can get, what we know today, and I think there is an agreement on the scientific level as well, the beneficial radiation is the ultraviolet B, and you can get the highest portion of UVB at noontime. And there is even a recommendation from the CIE, which is the Community Internationale d'Éclairage, so it's the International Lighting Commission, and their recommendation is you have to expose large areas of your skin, so to say it's best to stay out in the sun naked, but then for a relatively short time, which means 20 minutes naked at noontime gives you the highest benefit and the lowest risks.
Oh, interesting. Is the risk higher in the noon or in the AM or in late afternoon? Because you're getting more UVA in the AM and more UVB in the noon. So, and UVA is generally more risky than UVB, if I'm not mistaken?
There was a development in photobiology. In former times, the estimation of the phototherapists and photobiologists was UVA is completely harmless and UVB is the harmful radiation because this makes you sunburn. But in the meantime, the science has developed in a way that we know both is important. We need UVB and we need UVA, and we need it in a good ratio. So the amount you can get from sunlight, the amount of UVB and UVA and the ratio of UVB and UVA, this is what you get under natural conditions, and we can suppose that we are accommodated best to what we can get in nature. So it wouldn't make sense to extract UVB, for example. But the ratio of UVB and UVA in terms of high vitamin D production is optimal at noontime. And when you go out into the sunlight, let's say at 5 p.m., there's no UVB radiation left, so you have to say goodbye to the vitamin D benefits.
Right.
In this case.
So you think somebody should mainly focus on getting sun in the afternoon because you're going to get the full spectrum?
In the afternoon, you do not get the full spectrum.
Okay.
So UVB is missing. And in the late afternoon, it's, let's say, probably for cosmetic purposes, you might get a tan, but you will not get the medical benefits from vitamin D production.
I meant to say the noon or maybe a little after, maybe from 12 to 3 or something. But you're saying noon is, you have to get the sun by about noontime?
If you get the sun at noontime, you can reduce the exposure time. And this shifts the benefit-risk ratio into the benefit direction.
Ah, I see. Okay. It allows you to get more of the benefits in a shorter time and with less risk. So that's why you want to focus your time there.
Exactly.
And you would also say it's beneficial going outside as soon as you wake up, kind of to reset your circadian rhythm. Do you say that's also the case?
It's always good to be in contact with your natural lighting conditions, which are given by the sun. because they allow your organism to fully adjust to your environmental conditions. But it's always a question of dose and how people nowadays sometimes handle sunlight. Let's say if you are on vacation, I was several times in Las Vegas, and if you are in the area around the pool there, you will find people who are at the pool from 10 a.m. to 6 p.m., for example. And I don't think that this is a reasonable behavior, because you have to accommodate to this particular kind of behavior. It's not really fun to be out in the sun for several hours or probably the whole day.
Mm-hmm. Okay, now I've heard that UV can't get through certain locations. One physician told me that the bioplasma of New York City is not allowing me to get UVB or UV in general in the summertime even. Or maybe there's pollution, or he mentions non-native EMFs. What do you think of that can interact with the UV and you wouldn't be able to get the full benefit? What do you think of like those factors and UV? Do you think they have a negative impact in our ability to get UV?
So, of course, in big cities, we have air pollution, we have smog conditions, and this was the first signal that physicians did get about 100 years ago, when they found out that in the cities the children suffered from rickets. And the reason was that the dirty air, the air pollution, just filters out the UVB. But you can easily find out if your area provides enough UVB, if you would get, or if people around you get a sunburn, then you definitely have enough UVB coming through.
Okay.
So this, but you shouldn't. Of course, I already mentioned this. You shouldn't go to this limit.
Yeah, I don't go to that limit, but at least I know I'm getting UV in New York City. Now, this is a little, a little off the track, but do you think non-native EMFs are harmful?
There is an interesting study, a scientific paper from the Karolinska University in Sweden, in Stockholm. It's a few years ago that it has been published, but they found a connection between melanoma and electromagnetic fields. And it was in the 1950s when the ultra-shortwave broadcasting system and TV broadcasting system has been unrolled in several countries in Europe. And in these years, you could find an increase in malignant melanoma mortality in these countries. And in other countries in Europe where they did not roll out the broadcasting system in these years, there was no increase and no change in the mortality and incidence for the malignant melanoma. And this gives you an idea that there might be a connection between electromagnetic fields, the 1 meter band, the ultra-shortwave band, on one hand, and the light band, UV band, where the atmosphere is transparent for. We are talking about windows, atmospherical windows, which means in these parts or in these spectral regions, our atmosphere is transparent. And if there is higher solar activity, you can expect another ground level of electromagnetic radiation coming from the sun, which is not in the light part of the spectrum, but in the electromagnetic part of the radio waves. So maybe, and this is what the researchers suggested, there is another detection system in our organism which adjusts to electromagnetic activity levels, and not only for the ultra short wavelengths, but for the light activity, for the tolerance of skin as well. So there could be a connection. And I think the non-natural EMFs, if you can avoid them, it's always a good idea.
How much of someone's blood will be irradiated with UV if they're getting, let's say, an hour of sun? Because there's like treatments for UV blood irradiation. How would that compare to someone just naturally getting sun for an hour?
Well, this is a question I cannot really answer very swiftly or abridged, because what I can say, when you are out in the sun, the blood flow in your skin increases massively. So you will have about the blood contingent, maybe you have 5 liters of blood in your system, and this is the blood flow for 1 minute. And if you're sweating, if your body has to cool down under the influence of sunlight, it can be even more than 5 liters in 1 minute. So if you're staying out for 1 hour, you can make the calculation. It's several hundred liters of blood.
So that would be equivalent to something like whole blood UV irradiation or something like that.
It's very difficult to compare because with the ultraviolet radiation of blood, you are using ultraviolet C at 204 nanometers. This is a wavelength which never will reach the capillaries in your skin, but you only radiate, let's say, 1% of the blood you keep. So, for example, 50 milliliters will be irradiated with ultraviolet C. Mm-hmm. So this is not easily it's not so easy to compare the ultraviolet radiation of blood, which is done through a quartz tube with very short wavelength UV radiation, and what comes through your skin.
Mm-hmm. Is that one mechanism by which the sun can help people deal with infections because it's irradiating a large part of their... So if you get sun over a couple days, let's say you get an hour of sun over 3 days, you're going to irradiate most of your blood in your system over that period. And we know infections can't really survive well with UV. Is that like a mechanism by which sun may help people with chronic infections?
I think it's not so easy to... You have definitely a shift in immune activity, but the first go, your system needs to know if there is an inflammation. Is the inflammation induced by bacteria or viruses or fungi, or is it from a physical stimulus? And so, under the influence of sunlight, some immune cells will be depleted and will be deactivated, and others will be stimulated. So for chronic infections, it is more stimulating the system as a whole in order to build up, to make a switch in the immune system, in your whole system, to induce a switch in your reaction forms. And this is always a problem in chronic diseases, that the way your body deals with the problem is not adequate. And so you have to switch the reaction pattern. And for that purpose, it might be helpful. And talking about an American light therapist from the beginning of the 20th century, John Harvey Kellogg, he even would use the sunlight in a very, under recent ideas, brutal ways, because he used 3 times, 5 times the MED dose, the minimum dose, so that the patients would develop blisters under the treatment. But in these days, they had no choice. Today we have antibiotics, we have a lot of pharmacological products, so we don't have to make these, in our nowadays viewpoint, brutal treatments. But it was good for changing the reaction patterns.
That's interesting. So we know that sun is, UVA, UVB is generally an immunosuppressant, but obviously then vitamin D is going to be something that increases the innate immune system, the active form of vitamin D, and then sun will also increase superoxide and free radicals, which can directly combat infections. Is there any other mechanism by which maybe stimulates the immune system to get rid of infections?
You mentioned the vitamin D, and the cathelicidins are a class of molecules which help the organism to fight germs. And so, in a way, our organism tries to find a workaround. And if the immune system is damaged in a short term by an overdosage of ultraviolet radiation, the workaround would be you have an increased vitamin D production and you have increased cathelicidin concentrations, which, on the other hand, can help you to act against the germs.
What about vitamin D supplements versus getting UVB? As far as the active form of vitamin D goes, we know that UVB will convert to an inactive form of D3, and then that'll convert into 1,25-dihydroxy vitamin D. Now, is the sun better at increasing the active form of vitamin D versus vitamin D supplements, or it doesn't really make a difference?
Oh, this is subject to massive discussions in the scientific area. The specialists they did not find a consensus on this question up to now, but there are several ideas about it. For example, if you ingest the 25-hydroxy vitamin D, then it will be transported not only by the D-binding protein, which is a transporter protein specifically for vitamin D, it will also be transported by lipoproteins. And the lipoproteins, I compare this with standard mail and special delivery or express mail. If you ingest the vitamin D, it will show a different distribution pattern in your body because it's not mainly bound to the D-binding protein, but also to the standard lipoprotein molecules. And this means that it might not reach the same cell types if it's bound to one or the other. Priority mail versus standard mail is my comparison to get an idea about the difference.
What if you overload the system and you give it such a very high dosage of vitamin D? Wouldn't it distribute it to all the tissues? Because you're going to overload the lipoproteins. Or is that not something you'd recommend?
Yeah, maybe there's a flush a short while after a very high dosage, but the question is if these high dosages are really recommendable. Sometimes people reach doses by oral supplementation they would never be able to reach via the natural pathway, via sunlight. Maybe we have to even discuss if there is a dependence from, for example, skin type. At the moment we have a specific window which seems to be optimal, but only under epidemiological examination. But individually it might be the case that skin type 1 needs much less vitamin D than a skin type 6. And this would be just logic under the rules of evolution, because the skin type 6 has been exposed, the ancestors and relatives had been exposed for hundreds and hundreds of years to very high amounts of ultraviolet B radiation. And this means, under the laws of evolution, the organism learned to deal and to function optimally with high vitamin D levels. But this is not applicable to people, for example, in the Baltic region, a Norwegian person, for example, with Norwegian ancestors, with red hair and skin type 1, had to learn how to survive with a minimal vitamin D dosage. And so maybe in the future we will have to examine these aspects as well. And this is what I do when I treat my patients and when I give recommendations to my patients. I look at the skin type and then I get an idea if in the ancestral history there was tendency to a lower level or tendency to a higher level, which means, For example, for skin type 1, 20 nanograms per milliliter could be a better dose than 50.
There's talk about, like, let's say when you get vitamin D from the sun, it's sulfated versus if you take it internally. Do you think that has an impact, or we end up sulfating it anyway if we take it internally? What do you think of the sulfation issue?
This is a question I cannot contribute that much because I didn't find robust information on that issue. What I know, and this is an issue which has been discussed in decades ago, is that there is an influence on the sulfhydryl groups in proteins. And from that aspect, I can imagine that there is something going on with the sulfur metabolism, but I have no clear idea about that.
Okay, now we absorb vitamin D3 through our skin. Now, how does showers interact with that? How long do we need to keep it on our skin for us to get enough D3 until we wash it off with soaps or whatever we're using? Just water, maybe.
I think when we look at the dihydrocholesterol, which is the precursor molecule for the vitamin D production in the skin, it has the highest concentration in the area of the basal membrane of the skin. This normally you would not reach just by showering, but I think the habit of cleaning our skin with detergents which change the lipid metabolism in the skin, which make the skin thinner. For example, when you do not get a shower for a week or so, your skin will become thicker and thicker. You might not want to try this out, but nowadays, but we have to suggest that in former times when we are talking about humans 500 years in the past, or 1,000 years, or 10,000 years in the past, they had different behavior in terms of taking care of their skin, and they didn't use detergents in an amount we do nowadays. And so we take fatty substances out of the skin using these detergents, and so there will be an interaction. We put creams and lotions onto the skin afterwards because it starts to itch if we don't do that. Again, we add substances. We are not sure about how they interact with these processes in the deeper area. But what we can tell is that we find the substances from cosmetic products in the bloodstream after application. Mm-hmm. So these substances will pass through. What comes out and how we wash it out, it very much depends on the frequency of taking a shower. And so I heard this year, or was it just recently, that the Americans think we Europeans are dirty because we only shower once a day, and you do it up to 3 times a day in the statistic average. So it's very difficult to make assumptions in this field.
I see.
If you take a shower just with plain water, you will be fine. If you rub your skin and take off the corneocytes, then this will be a different story.
Interesting. Okay, I noticed that sun makes me a lot more tolerant to carbohydrates. Like normally I'll get tired if I eat too much carbohydrates, but that tolerance goes up when I have more sun. My guess is that it's from nitric oxide, which can stimulate the wakefulness neurotransmitters in the brain. Do you have any take on that? Why you'd be more tolerant to carbohydrates? Some people suggest that, sun correlates with more carbohydrates. That's like the fruit season. And we're kind of designed to go with that. So when there's more sun, we can tolerate carbohydrates better. What do you think about that?
We know from Roman times or in ancient Greece, there was already the idea that the metabolism will be changed under the influence of sunlight. And I think this, all the examples you were mentioning, they are connected to what I call seasonal stress hormone. The vitamin D as a seasonal stress hormone changes our metabolism in a way that we can perform better under the influence of sun during the summer. It was in former times during the summer. Today it's a completely different story. I don't think that we really have these characteristics of seasonal changes anymore, because we changed our lifestyle significantly in this regard. But the vitamin D as a steroid hormone definitely will have an influence on metabolism, and this means tolerance for fat, for lipids, for carbohydrates, and proteins, of course.
That's interesting. Now, you mentioned that it's not good to get sun through a window, I believe. Is it better to get sun through a window or not get sun at all? Like, a lot of people have offices and they're working by a window that's getting sun next to it. What do you recommend for that?
Yeah, it depends. If you use the light coming through the window for general lighting purposes, then it's, of course, much better compared to shielding and using artificial light sources instead. But the windows significantly change the spectral composition of sunlight. So many modern windows filter out the infrared A portion, and many windows do not filter out the UVA, so you will not get a sunburn typically behind the window. But still the UVA radiation is there, and if someone sits directly behind the window for many, many years and you have this direct influence of sunlight on your skin, then you should try to avoid this in long terms.
So you try to put some kind of covering that blocks out UVA, but maybe allows the full spectrum in? Or I was experimenting, you could see behind me, I put like a red shade on there. So it blocks out everything except like red. And then I leave my windows open as well. So the portion of my windows that are open, everything goes through, and the portion that's not, it's blocked out. What do you think of that?
So I think we should not try to make heliotherapy or sunlight treatment when we are inside our caves, because you are in clothing, and when you sit in front of your computer, for example, and if you get direct sunlight, even through the window pane, this will probably induce an overdosage in long term. I'm not sure about the using the red filter. If this is, if you feel comfortable with it, then it's okay, because this will take out the short wavelengths more or less completely.
Right.
But I prefer gray filter better. I prefer them instead of using always the same color, because the colors themselves, they have particular potential to act as a stimulus, as a photonic stimulus. And if you would use the red filter one day, green filter the other day, the next day probably a turquoise, and then a yellow, you would get a kind of balanced exposition over the time. But if you always use the same color, I'm not so sure about the long-term effects.
Oh, I see. That's a good answer. I know this is going to be a very big guesstimate, as in you cannot say for certain, but try to give your best educated guess as to what percentage of the sun's benefits is from vitamin D, infrared, UVB, UVA, the color spectrum, color intensity, or other beneficial properties.
I really did hope that you would step over this question, because, or no, I can give you an answer, but it's not the answer you might want to have, because I think the sunlight was there from the very beginning, and it was the task of the living organisms to deal with the sunlight. And the sunlight consists of less than 8% of ultraviolet radiation, less than 5% infrared B radiation, and in between we have the visible part and we have the near infrared part, and it's the spectral composition. Let's say sunlight is a very specific cocktail, and if you just cut off a tiny part of what's there in nature, the cocktail will taste different. And if you replace the juice by gin, so you have pure alcohol, this will definitely make a difference. And sunlight is beneficial for those who are accommodated or adapted to it. Which means if your ancestors lived in Africa, then you will have a different adaptation mechanism or different adaptation mechanisms. And our body takes advantage from every part we find in sunlight. And we really need, in my understanding, good arguments to amplify certain parts or to leave other certain parts apart. For example, there's a kind of law or finding that the shorter wavelengths, they are stressful, the longer wavelengths are good for regeneration, and it's in sunlight, it's in a balance, in a good balance. And from that perspective, and looking back through the history of photobiology and photomedicine, they started with extracting several parts of the spectrum, and they had the idea they can make it even better than nature. But in the end, it always turned out that it was not a good idea to amplify or to deplete several parts. Mm-hmm. It's the full spectrum which makes sunlight so healthy, and if we change this in one or the other direction, I'm pretty sure that in the end it will turn out as a bad idea.
Mm-hmm. Okay, that's a really good answer. So basically I was thinking about it in too reductionist of a way, and it doesn't work like that. But let's say, can you still answer like what percentage of the benefits are from, let's say, vitamin D? Is that something you can answer? Like as a guesstimate, is it like 20% or like 10% and the rest is from other sun benefits? Because there's an emphasis on vitamin D. Oh, I'm not getting sun, I'll just take vitamin D. And I keep on trying to tell people that it's a small part of the story.
Yeah, I understand. And for that reason, I would say it's probably 10 to 20% of the benefits we can get from sunlight come from vitamin D. It's a much bigger story. And for that reason, I'm not really comfortable with quantifying the benefits in such a detailed way. We need the vitamin D, but not every person needs the same amount, and it depends on, for example, when you are, if you would have red hair, I cannot tell because
absolutely not.
People with red hair, they have a different type of melanin. It's not the eumelanin, it's the pheomelanin, which is an intrinsic photosensitizer, which increases the amount of reactive oxygen species under the influence of sunlight. And so it's very difficult to say it's 20% because skin type 1 maybe will not benefit from sunlight at all. And people feel, if they don't feel comfortable in the sunlight, then there is a lot of thinking to do. Because the best protection and to increase benefits and to reduce the risks is our human intelligence. And this tells us that we cannot give these simple recipes. And an example for a simple recipe is what the World Health Organization does, or many dermatologists do. They say, stay out from the sun because it's harmful. This is a simple recipe. And it's difficult if the better recipe is complex, because it's not so easy to reach people.
So do you think, you said we cannot replicate full spectrum. Do you think that the modern environment is in any way giving us more of one, let's say in Australia, right? There's supposedly a donut hole, more UV comes in. So, or let's say pollution in some places. We have like the modern environment is kind of making a different emphasis. They're taking out different parts of the sun than we had in our evolutionary past. Do you think that is having a significant impact, or it's relatively minor?
When we are talking about benefits of sunlight, we always have to talk about the location, the elevation, the height of the area we are living at, and to make it simple and short is when you are at a particular country. Look, for example, in Australia, the native population looks pretty much different to the immigrants from England which came to Australia many, many years ago. And so that we have an increased incidence for skin cancer, for example, especially in Australia. Look at the Aborigines and at their skin type, and look at the major population in Australia who are living there nowadays, and you get an idea why we have this increased incidence for specific types of skin cancer.
So you think it has more to do with people not evolving in a certain area rather than maybe ozone or some environment pollutant destroying the atmosphere in some way?
I don't think that we guarantee that there was no ozone hole 10,000 years ago, because every eruption of a volcano adds some gases into the atmosphere which may deplete the ozone layer as well. So I think that there is, in Australia, we have elevated amounts of UVB radiation, and the kind of proof will be very difficult, but look at the Aborigines living there for tens of thousands of years. It must have a reason that they have a darker pigmented skin. And looking at the theories and hypotheses from Nina Jablonski, for example, she gives a very good example for the reason why you have differences in pigmentation independence of the local radiation levels.
Mm-hmm. Interesting. Now, can you explain why getting sun or UV is better at higher elevations? Yeah, they have some kind of celebration next door. Move this. Sorry about that.
You look much different now.
Because I closed all the windows, so it's only red coming in. Oh my gosh. Okay. So why is the sun better at higher elevations?
Yeah, you have a thinner layer, atmospherical layer, and UVB will come through much better. So this is the reason the higher you are, the higher is the percentage of UVB radiation, and so you have an increase of the benefits, for example, from vitamin D, but capillary reactions and so on as well.
So if you're higher up, you say you get more UVB, but if you're lower, like if you're at sea level, and you're just exposed to the sun for longer, would that equate to the same thing as being at a higher elevation? Would it be the same health benefits? Or there's something else that cannot be attained at a lower elevation?
If you are at a lower elevation, then you would have to stay longer outside to get the same amount of UVB, but in that case you would shift the ratio between UVB and UVA. So you cannot compare this one-to-one.
Okay, I see. So you're saying overall it would be healthier with regards to the sun to living at a higher elevation. But as we know, the higher up you are, the more hypoxia that you have, the lower oxygen concentrations. Do you think that overall it would be more or less healthy living at higher altitudes?
So I would look at the inhabitants there, for example, in the Alps, in the Alpine region. My impression when I'm there for vacation is that people are quite healthy there, and they might have some kind of sailor's skin from time to time, so you can see that there's a higher impact of sunlight on their skin, as long as they do not wear, for example, hats and do some textile sun protection on a regular basis. But I have the impression that people living in higher altitudes they are quite healthy. This is just guesswork. I don't have any epidemiological data to back this.
Okay. How do some people get tired from the sun? My guess is that nitric oxide could cause fatigue in some ways. Is that from nitric oxide, or is there other mechanism by which people get tired from the sun?
Maybe we would have to define tiredness. Because when I'm taking a sun bath, then I get in a kind of trance-like state. It's not that I'm really tired. My system slows down in a way, and I have a lot of thinking, for example, with eyes closed, but it's not really sleep. It's a kind of intermediate state. It's a kind of trance-like state I experience when I'm in the sun. But what happens from that part is that you could easily fall asleep at a certain moment, and this is of course very dangerous to sleep in the direct sunlight. So this is something to take into account. When you go into the sun, you need an alarm clock or some other tool which would wake you up in case that your trance-like state gets too deep. And there are, I think, for sure several reasons. Nitric oxide might be one reason, but there's a constant intensified stimulus acting upon the dermal nerve cells and sensory system. So we know that, for example, if you increase the neural stimuli on the eye by using blinking machines, or if you have loud auditory signals, then this kicks you in a different kind of state of consciousness. And I think this is one very important aspect in sunlight, that the state of consciousness shifts from being actively in our eye and ear sensory system it shifts into the dermal awareness.
Mm-hmm. Now, nitric oxide can be both good and bad in the research. There's INOS, which is bad, and there's ENOS and NNOS, which is generally good. And the reason I'm asking you about nitric oxide is because I think UVA is something that's increasing nitric oxide mainly, and I think it's important to know, when is nitric oxide good or bad in the body? How does that work? Because it can be both good and bad. How would you explain it?
It's the same story with other reactive oxygen species. Is the same story with sodium chloride or with water. It's always a question of the right dosage. And as long as there is nitric oxide signaling going on, as long as the dose is in the tolerance level of your organism, everything's fine. And if you exceed the dose, if you increase the concentration over a certain threshold level, then it will be harmful. It will become harmful. So this is always a question with reactive oxygen species as well. They are called Janus-phased molecules, and if you have too many of these molecules, it has negative consequences. If you have not enough, you have negative consequences as well, because you will have an impact on the signaling. And all these substances in our body which can be toxic, they have threshold levels. Beyond these levels, they will not be toxic. They quite often exhibit the opposite activity.
Why are some sensitive to bright lights? This is a common symptom, especially in people with chronic fatigue and those kinds of issues. What is the biological mechanism by which they're sensitive to bright lights? Are you familiar with that?
This is not so easy to answer, because there are, again, several possible explanations. For example, if someone has migraine, there is a common pathway between the light signals and the trigeminous nerve, and you have some shortcuts between these two neural pathways, which can lead to an overstimulation of the trigeminus, for example. It has to do with accommodation as well. So if someone, for example, is chronically sick, this person will preferably stay inside. And if you are not accommodated to bright intensities of light, then it's a difficult start. You have to do it stepwise, step by step, and with very small doses of exposition, and then increase the exposure time in a small increment. Mm-hmm. But again, it's not so easy to give general rules on that or general explanations, because the different disorders, they follow different mechanisms.
Okay. Now, what about people like lupus or certain other autoimmune conditions? Why do they have a problem getting sun? And what would your recommendations be for those people?
Yeah, again, we are at the point that not every person, not every individual benefits from sunlight. And for example, xeroderma pigmentosum patients, they cannot even stand artificial light from a certain intensity on, because they have missing repair mechanisms in their genes, and autoimmune system based disorders, they can make a patient susceptible to specific parts of the light spectrum for UV, but there is also a mechanism, for example, in the longer wavelengths, in the red part of the spectrum, where you can increase the fibroblast activity. And, for example, collagen disorders and autoimmune reactions to the collagen, they can lead to adverse reactions even from the longer part, the longer wavelengths in the spectrum, for example, red light or near-infrared light. And the recommendation is, of course, people should not trigger these adverse reactions if they can avoid it. They should avoid exposition. The same question, if someone has a history of skin cancer, it might be the best decision to avoid solar exposition.
Mm-hmm. So if someone's had skin cancer, what's the recommendation? Should they stay away from sun or not?
You always have to evaluate the benefits versus the risks. And if someone becomes massively depressed by staying in the dark, then it might be a good idea to get the right dosage of sunlight even after a personal history of skin cancer. But it definitely depends. We have different kinds of skin cancer. We have basal cell carcinoma, the squamous cell carcinoma, we have the melanoma. The risks are very different between these different types of skin cancer. And there's one positive thing, that if someone develops a basal cell carcinoma or a squamous cell carcinoma, it is on the surface of our body. So this is a type of disorder which can be detected and spotted at a very early stage. And so you can treat it quite easily the earlier you detect it. And this is the positive thing about it, but it's mostly impossible to give a recommendation on a general level to someone who has a very individual history of disease or disorder.
I agree with that. That was a very good answer. Now, would you ever recommend sunscreen to somebody, or you would just recommend staying out of light or wearing a hat or a shirt? What's your recommendations with that?
So before I would recommend using sunscreen, I would recommend to draw all the registers of textile and behavioral protection, because sunscreen always interacts with our system. And we have here in Germany, for example, or in Europe, we have two different types of sunscreen. The mineral-based ones, which only build up a layer on the skin,
Mm-hmm.
and the chemical sunscreens, which are absorbed by the skin. So they enter the skin and they even enter the bloodstream. They change the concentration. They act as endocrine disruptors, for example. You can even detect them in breast milk in lactating mothers if they use the chemical sunscreen types. So when you look it up in Wikipedia under the keyword of photoprotection, you can get an idea about the amount of additional nitric oxygen species which are produced in the skin because these chemical sunscreens act as photosensitizers. It depends. If you use it, let's say you are on a ship or you are together with friends on the beach, and you forget all your textile protection means. And the only way to protect yourself, you cannot escape, and the only way to protect yourself from sunburn is to use whatever sunscreen you can get. You should do that because this helps to avoid developing severe sunburn. But my understanding should not be the everyday strategy to avoid solar overdosage.
I like that answer. What do you think of, there's a company called BlueTech in the United States. They sell glasses that take out a shade of blue from the UV spectrum. There's no distortion of regular blue, but the blue outside, the UV spectrum of blue is taken out. Now, some people recommend that because they say that blue light causes photooxidation of DHA in the eyes, and that causes a bunch of problems with the circadian rhythm and other effects. And other people just wear them because they have a bright light sensitivity. Do you suggest generally healthy people would wear such glasses, or you think we should just be getting the full spectrum of blue all the time that the sun has to offer?
I would not recommend to use them in terms of protection from solar radiation, because here I think the gray filter is much better, because the gray filter does not change the ratio between the different parts of the spectrum.
Oh, I see.
I very much recommend to use blue light protection glasses, and I developed blue light protection glasses with a company in Germany myself.
Mm-hmm.
So if there is, for example, if you have light sources with an elevated amount of short wavelengths and missing long wavelengths in the red and near infrared region, then I think it's a very good idea to use the blue light protection measures. But in sunlight, we have to ask ourselves, why do we have these non-vision forming receptors which are sensitive for blue light? Why do we have them in our eyes? And my concept of explaining the existence of this sensory system is that in nature there is a connection between blue light and ultraviolet light. Ultraviolet is invisible, blue light can be seen, and blue light can be detected with these receptors. So if there is the risk for solar stress, for UV hazard, then this will be signaled by an intensified content of blue. So if we are outside, and anyway, if we just block out the blue, or if we reduce the blue using sunglasses, our system is not alarmed by this signaling pathway, which uses the blue part of the spectrum. So wearing sunglasses would more or less necessarily ask for using sunscreen or protection of the skin by any feasible means, because sunglasses and blue blocking glasses reduce the alarming function, the visual alarming function of our eyes, which lower our adaptation potential concerning, for example, the UV hazard.
Mm-hmm. What about wearing glasses, regular glasses for myopia or things like that in the sun? Because the glass is going to filter out certain spectrums. You say when you go outside, you should try to minimize the amount that you're wearing glasses?
When we change, it depends on the filter properties of the glasses. For example, when I have an infrared camera, and if I would take a picture, a live picture from your face with the thermal camera, your eyes would look like black holes in the thermal picture, which means the correction glasses you are wearing, they will definitely have an impact on the invisible parts in the long wavelength. They, on the other hand, will have a filtering impact for shorter wavelengths than 400 nanometers, but it will definitely change the radiation which reaches your eye, which reaches the retina. For that reason, for example, if we reduce the near-infrared part of the spectrum, this might be a bad idea because it's in the natural spectral distribution in sunlight, we have more than 40% in the visual part and more than 40% in the near-infrared part. And when they come together, it's a balanced composition. And when you filter parts out, then you cannot guarantee that the physiological reaction will be the same.
So do you think that if somebody, a lot of people obviously live in places where they're not getting sun for most of the year or half of the year or whatever it is, or even the whole year if people have office jobs and things like that, is it better to use UVB lights or maybe even lights? I have lights with like a spectrum of UVB, UVA, and it's also a heat lamp and maybe it gives off infrared. Or people should just be using a UVB lamp. I mean, like, what should people use these kinds of artificial lamps if they're not getting sun?
It depends on their individual needs. If some people really depend on sunlight or on light, and people who are magnetically drawn to tanning salons, they are in need for light. Mm-hmm. And I think the majority of the population depends on light and needs the stimulus, needs the training effect light can unfold in our system. And those who feel that they are in need for more light, they should listen to their body talk. If the body tells you that you need it, then it's good to go for it. And the question is, what is the best light source? Or, for example, is it really a good idea to travel to an equatorial region during winter time? Does it really give you the positive effects you're expecting from it? Or would it be better to stay in your region and just use appliances which can add some more light to your existence?
You mentioned that it's important to have vitamin D levels pretty steady throughout the year. Why is that so important?
When we think back for, let's say, 200 years, and let's say seen in the Austrian or Swiss Alps, where people live with their animals, they are exposed to sunlight during summer, and during winter the cattle is in the stable and they have less activity, it's much, much colder. The thermoregulation has to switch over to winter condition. So if people really would live intensely with the different seasonal stimuli, and if they are exposed to the seasonal climate conditions, then it's a good idea to have undulating changes in vitamin D supply, which means you have high levels during summer, you have low levels or lower levels during winter time. But we are not living in these conditions anymore. Our environment is well tempered.
Well, what's the mechanism there? So you're saying if the temperature fluctuates and it's cold, then we can go lower on the vitamin D like our evolutionary ancestors. But what's the mechanism by which cold will allow us to have less vitamin D, or if we don't have it, we'll need steady levels? What's the mechanism there?
I imagine that we have some molecular switches, that vitamin D is the signaling molecule for the conditions, and it's not only avoiding sunburn or building up vitamin D just for the bone structures or calcium metabolism. It is also changing the thermal regulation, for example, adjusting the metabolism of water in your system, influencing the kidneys, influencing that you have enough water in your system to sweat for sweating, for example, so that you can cool down your body in case of overheating under the exposition of sunlight. Energy distribution, we have about 1,300 watts of input per square meter. And this has to be digested in summer, and it's not there during the winter time. So in summer times, your body needs more water, for example, to give away for the purpose of sweating, just as one example. But it's a very complex thing. Look at the different effects of the steroid hormones, which regulate the cardiovascular function, regulate thermal functions, the reproductive activity of steroid hormones. It all is linked together, and today we are not exposed to the seasonal climate conditions in the same intensity as it was in former times. I have the example of a moose living outside during the winter time, during the summertime. A moose has to invest about 25% of the body mass to survive winter. And this goes along under natural conditions with a change in the vitamin D concentration. And so, since we do not have the winter time conditions as we had it, as our ancestors had it even 100 years ago, I think it's better to have, since we live in under equatorial conditions, more or less, we can extend the light cycle. We have less darkness in winter because we use artificial light. Right. We have 20 degrees of Celsius in our rooms. So the thermal regulation is shifted. We are sweating more in winter than freezing, right, in a way. And for that reason, it would be a kind of logical consequence to have, if we have kind of summertime throughout the year in our environment, we should have the
vitamin D to go with it.
Yeah.
I see. That makes sense. Now, as far as light at night, I have a couple questions with that, and we're going to end the interview there. What intensity of light can disturb your circadian rhythm? And if you just block out, let's say, blue light, is that enough for your circadian rhythm to be set in normal ways, to function in a normal way? So number one is the intensity and the spectrum. What exactly do you need to do? Like, I'm in New York City and stray lights are coming in from outside. Is that enough to disturb my circadian rhythm?
Even tiny amounts of photons at the wrong time of the day, or it's especially not the day we're talking about the nighttime condition. And if you reduce the amplitude of brightness during the day and darkness during the night, this will have negative consequences to your circadian rhythms, which means you should avoid, after the sun has set, every kind of artificial light source will have the potential to disturb your system. But when we see it in the evolutionary context, then we can get the idea that our system can cope with candlelight intensities quite easily, because we had fire. Our ancestors had fire since thousands of years. So we had the chance to on the evolutionary level to adapt to these low light levels.
What about the stars and the moon?
Yeah, the moon will give you about 1 lux.
Oh,
and
okay.
When you live under natural conditions, it's always a good idea to have not only the circadian rhythms, but the lunar rhythms as well, because the moonlight would give our ancestors the chance to stay awake during night times for hunting, for example.
Mm-hmm.
And in these times, if you're out for hunting during the night, it's a good idea to be a little bit more active compared to nights which are pitch dark. So there are not only the circadian rhythms, we have infradian rhythms and supra or ultradian rhythms, which means the lunar cycle, the seasonal cycles. And this is a very tricky or a very subtle way our body can adapt to. And if you are living in a city like New York City, it might be a better idea to shade the windows in a way that the stray light does not come in, because stray light will have a higher influence or a stronger influence than the sometimes maybe the moonlight when it comes through. But as I can recall, artificial lights in New York are so intense that the moonlight will not play a significant role in this game.
No. Yeah, they're pretty intense. That's why that was one of the reasons I shaded my windows with red filter. So any light that does come in from outside is going to be red. But I wear red glasses before I go to sleep for a couple hours, maybe 3 hours. And that's going to block out blue and green light. So green light has some impact on the circadian rhythm, not nearly as much as blue. But would you say it's better to get complete darkness rather than some kind of light? But even though the blue and green is filtered out?
It won't help you to use red glasses in the end if the intensity of the light surrounding you is high enough. Then you can even achieve melatonin suppression with red light.
Oh, that's interesting.
From the Lighting Research Institute in Troy, for example, there are some papers around available which describe melatonin suppression effect from red light as well. But I think as long as you have every artificial light source after sunset will reduce the amount of melatonin which flows in your system. And it will reduce the regeneration time for the cone receptors in your retina. And it is not realistic, in my understanding, to try to stay in pitch dark after sunset in our nowadays society. But if you are aware of the problems that the good light might be a good light during the day and might be the same light might be bad during night times. And in our lighting concept, it was just a one factor or a one trick. Let's say it was a one trick pony we were dealing with for many decades. And in the meantime, there is a shift in the awareness of the different lighting conditions that we learn and understand that we need more natural light during the day and less artificial light during night times or during evening. And the red glasses might be one option. You can do probably better with amber glasses or highly saturated yellow glasses, because we are quite sure that the short wavelengths have a much higher impact on melatonin suppression than the longer wavelengths. And avoiding green, the red is, it's I could see it before when you put down your red filters. It changes with the red, you eliminate color vision completely. And with yellow glasses or amber glasses, you still have some discrimination between green, lemon, yellow, orange, and red. And this is hard.
You recommend those over like the red glasses? Even though you're right, red can suppress, let's say, melatonin, but you need lower levels of green and even lower levels of blue. But you still recommend yellow glasses over red glasses because just it's more convenient.
Color rendition for For example, if you meet people, if you are in a social environment, it will have a deep impact if you wear red glasses, because it takes away any kind of color quality from your environment.
Right.
And it depends. If you have the feeling that it's okay with the red glasses, then go for it. But I think a little bit more visual comfort in terms of discriminating the color from the middle part of the spectrum up to the long wavelength part of the spectrum. It is, if we had light in our evolutionary past, after sunset, it was fire, and fire gives you the spectrum from green, from turquoise, increasing up to the red. Uh-huh. And it has a very low short wavelength content, but in fire, you still can see green, you can see lemon, you can see yellow. And so it would mimic the evolutionary past under the influence of fire as a
That's very interesting.
Artificial light source.
Do you think that blue light on your skin can disrupt your circadian rhythm? So studies have initially found that they could, and then other studies can replicate them. What's your opinion?
I didn't make experiments on my own, and it's very difficult to experiment with colors on the skin, because it's mostly impossible to make a double-blind trial with visible colors. So how can you make a trial with this so that the examiner and the patient doesn't get what's going on? This is one aspect. The other aspect, I think it was Dan Oren who published the study with the light in the knee.
Yeah, in the knee.
Yeah, the more you measure, the more mistakes can occur. And I wouldn't say that Oren's experiments were not well made, but it was not possible to reproduce this. Uh-huh. In the meantime, we know, for example, from blue light application that it can influence the pain level which is felt, because it helps the body to produce nitric oxide. And this is just an effect which goes through the tissue, through the skin and the dermal layers. So I think there are effects, or I don't think, I know from own experiments, from own experience, that color which acts upon the skin can definitely have an effect. But I'm not sure about the effect on the circadian rhythm. I think it's very difficult to plan a trial which could bring this as a result.
Okay, and for the last question, is the Efflux program, if you're familiar with it, is that enough to, if you put it on the setting that gives off the lowest intensity of light, can that still disrupt your circadian rhythm?
Efflux program, yes. I made some spectral measurements with Efflux.
Okay.
I think it's a neat strategy to reduce the content of blue, but if you are afraid of the effect of blue, then let's say the ratio between the red and the blue is still 1:10 or so. So you cannot fully eliminate the blue content, because Efflux will not eliminate the LED of the intensity of the blue LEDs in the backlighting system of your screen. It only will block, or it in the TFT cell of a computer screen, you have a kind of polarization. So it's a polar filter which can switch, and the other is constant. And if you cross the polarization angle in a way that you block the light, you will not block the light 100%. You will still have you will not reach a full contrast ratio with TFT screens. For that reason, it is not possible by software means to eliminate the blue in the spectrum of your screen.
Okay, that's really interesting. And so I actually use the F-Lux and I use the glass as well, but sometimes I'm thinking maybe the F-Lux is enough, but I guess it's not. I really appreciate you coming in to talk with us today. Where can people find you, and if you have any products that you sell or anything like that, you can mention them now.
I have a website, or it's a blog called photonblog.de, and I have a website on chromotherapy, which explains the use of different colors a little bit more in detail. And the name, maybe I could send you the web pages via email.
Okay.
Because it's not so easy sometimes to spell and to get all the details of the web address.
Okay, sounds good. Thank you so much. I mean, this has been a really, really informative interview, and I'm sorry half of it I I looked darkened out. It's because they were having celebrations next door, and it was getting loud. Okay, thank you so much, and have a wonderful day.
Thank you very much, Joe, and same to you. Have a wonderful day.